All right, let's talk about quadric surfaces. Before we get into quadric surfaces, let's just refresh our memory on some objects in 2 dimensions. Remember circles, you know those. X squared plus y squared equals r squared. Okay, and that's just, let me actually draw that a little better. Like so. Okay, now we can actually do a little bit, we can extend that into what's called a sphere, right? So sphere, x squared plus y squared plus z squared equals r squared. And all that is, it's basically the same thing in 3 dimensions. Okay, now in order to draw it, I'm going to be a little bit tricky. The way I draw it with these things is I'll take maybe one like this, make it a little bigger. Let's get rid of the mind. Let's draw another circle, but this one I'm going to draw actually like an ellipsoid. Move it into the center here, and that's just how I draw them. There, that's my sphere. Some of you may be better at it than I am, okay? And that's just all it is, x squared plus y squared plus z squared equals 1. Let me draw this out. Okay, that's about as good of a drawing as you're going to get from me on this, okay? So now let's take a look also at ellipses and ellipsoids. So an ellipse, x squared over a squared plus y squared over b squared equals 1. Now when I teach this in pre-calc, just because of the way the book is, like a is bigger than b, we don't worry about that here. Okay, we just know that a is how it moves in x, and the b is how it moves along in y. So it'll go left, right by a, up, down by b. Okay, and we're going to draw the ellipse. Yeah, that's about as good as you'll get. Okay, and then you also have an ellipsoid. Okay, x squared over a squared plus y squared over b squared plus z squared over c squared equals 1. You take this whole thing and copy it. In this case, I'm going to make this x, this y, this z. And let me just, oops, that's not what I wanted to do. Okay, that's about as good. That's not so bad. Okay, you get the idea. Okay, it's going to go forward to c, backwards to negative c there. Okay, no problem. All right, let's do the hyperbola and the hyperboloid. Okay, the hyperbola is x squared over a squared minus y squared over b squared equals 1. Okay, so now what that is, again, you have a triangle, or I'm sorry, a rectangle that goes left, right, A, up, down, B, okay. Now, let me draw this A, negative B, B. I actually have some videos on now that I'm thinking about it on hyperbolas and ellipsoids. I will post them for you. Just remind me. And now, since it starts with the x squared first, okay, that means it's going to start at this point here and this point here. Okay. All right, so that's the sort of the refresh. Let's go ahead and now let's talk about a hyperboloid. So with a hyperboloid, there's a little bit something special that could happen. So that's why I'm going to do it separately. So let's start with the hyperboloids. This one's going to be what's called a one-sheeted hyperboloid. Okay, so I'm going to give you the equation first. It's x squared plus y squared minus z squared equals 1. Okay. Now, what I'm going to do, I'm going to play around a little bit. Okay? I'm always playing around, I guess, when I'm doing math. But I'm going to imagine something. So what I'm going to say is, I'm going to notice that these two, the x and the y, they pretty much act the same, right? So the z is sort of special. Okay? So what I'm going to do, I'm going to sort of put the x and y together in 1. This will make more sense later, I think, but I'm going to sort of just treat them as the same. So let's imagine the x isn't there. Okay? So let's do this as our x, y, z. I'm going to imagine x is just 0. Okay? I'm covering it with my hand, and that doesn't make any sense to you guys, but let's imagine x is 0. Okay? So I'm going to do y squared minus z squared equals 1. Y squared minus z squared equals 1. That's going to be a rectangle, 1, 1 in each side. So 1 up, 1 down. Okay. Again, this is in the ZY plane. I'm doing it. Let me draw just this piece. I'm just going to draw that piece. Okay. And then I have my hyperbola does this. Now, when I treat x and y as the same, what I'm essentially doing is I'm saying I'm going to rotate it around the z-axis. Okay. Okay, so when I rotate this around the z-axis, that means I'm going to get the same thing over on this side. And I'm going to get something rotated around here. Okay, so this is a one-sheeted hyperboloid because it's one whole structure. Okay. All right. So far, so good. Okay, let's change it around a little bit. Let's do z squared minus x squared minus y squared equals 1. Okay, this one's a little bit different. This is actually going to be a two-sheeted hyperboloid. Here's a two-sheeted hyperboloid. We're going to actually do it almost the exact same way. So I'm going to take, again, x and y are still the same, right? What I mean by that is that if I change x and y, it doesn't change anything, right? Same thing here. If I replace x by y and y by x, it doesn't change the equation at all. Okay, so I'm going to go ahead and pretend I'm going to do this with this being z, this being y. X is again going to be out here. Okay, again, it's going to be a rectangle. My fundamental rectangle for the hyperboloid is going to be, 1. But now this time, it's actually going to be a different hyperbola. Okay, because if I look, for example, z squared minus y squared equals 1, okay, that's actually going to start up here. Okay, so that's going to be a hyperbola like this. Okay, the other side of the hyperbola is down here. Okay, and when we rotate this around the z-axis, again, because you're using what's called a symmetry, and your symmetry is an XY symmetry. That's actually, there's a name for it. We call it azimuthal symmetry. I don't think they say that in the book, but that's the name I've seen for it. Okay, so that means we can rotate it around the z-axis, and we're going to get something like this. And you can see why it's called a two-sheeted hyperboloid, because there's two different pieces of it. Okay? All right, we'll come back. We're going to do a little bit more with these. I want to do a couple of problems. I want to show you a couple of tricks. So I'll be back. My mouse doesn't engage.